Hello everybody, I hope you're doing well and welcome to the platform of CodeChef. So today we're going to be solving the problem just subtracted. The difficulty level for this problem is easy and the prerequisites are your basic number theory. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try to understand the problem statement. So basically it's the time for IPL auction and you have an array of n players and an integer k, i.e. the number of teams. Each player has a base price of AI. You are allowed to perform an operation several times. You can choose any two players, let it be I and J, such that my 1 is less than equal to I is less than J, which is less than equal to N, present in the array, which has the same remainder when the base price divided by K, and you have to erase data of those pairs and append the absolute subtraction of the base price into the array. Your task is to find the minimum size of array that you can get after performing the operation as many times as you want. Okay, so let me just summarize this entire problem statement for you all. Basically, the question is told that I'll be given an array. So I'll be given an array of a integers, a1, a2 up till an. Then I'll be given an integer k, and the question has told what you can do is for any of the general I divisible by k, so let this ai mod k equal to r. So for the elements having the same remainder which are divisible by this particular k, which has the same remainder, what you have to do is you can just simply take any of those elements and then we can simply replace those elements by their absolute difference. So what I mean by that is let us understand using this test case. So here I have my array as 3, 6, 9, 12 and here my k as 3. So what I did is simply since my 3 mod 3 is 0, my 6 mod 3 is 0, my 9 mod 3 is also 0, and my 12 mod 3 is equals to 0. So all the remainder are the same. So we can at any time pick any two elements and replace the absolute difference with their we can replace those two elements with their absolute difference. So let's say I pick 12 and 9. So basically we can just simply choose 12 minus 9, which is 3, and then delete 12 and 9 and put 3 in the array. So the new array becomes 3, 6, 3. And then, as you know, my 3's remainder is 0, my 6's remainder is 0, and again my 3's remainder will be 0. So again, we can choose any two elements. So I choose these two elements, and I got 3, comma 3. And then I can choose these two elements, and I can get 3. So the final minimum length of the array that we can get is 1. And hence, the answer for this particular test case is 1. Right? So yeah, that is the idea. Sorry, the 3 minus 3 will be 0 and that's where the final product will be 0, but the length of the array of this final array is 1 and that's why the answer for this case is 1. So similarly, you have to find that for any generalized array, what can be the given approach or what is the minimum length we can reduce to. So here, as you know, by removing two elements and inserting one single element, we remove the array by one size, right? What is the minimum size of array we can obtain by doing certain operations? So yeah, let us see how we can approach this particular problem. Okay, now to approach this particular problem, firstly we have to understand one very important observation based on number theory. So consider I take my k is equals to 3 and say my array is certain generalized, say it is 3, 6 and say it is 4, 7. So firstly, let me just calculate all the remainders with 3. So my 3 mod 3 is 0, my 6 mod 3 is 0, my 4 mod 3 is 1, and my 7 mod 3 is also 1. Okay, now since these remainders are same and these remainders are same, I can choose two elements from here or I can choose any of the elements from here, right? This is what the question has told us. So now what we can do is, what the important observation that I wanted to show you all is when you subtract for any of the two generalized elements, say my A mod k is equals to R and similarly my B mod k also equals to R, then if I subtract my A minus B according to the principle of modulo, then A minus B mod k will always be equal to 0 if A and B satisfy this particular condition, and then the final result of A minus B mod k will be equal to 0 according to the principle of number theory or the modulo. So I can prove that by showing you this example that firstly consider my 4 and 7. So my 4 mod 3 is 1, my 7 mod 3 is 1, so my 7 minus 4 mod 3 should equal to 0. So as you can see, my 3 mod 3 will equal to 0, and hence this is the case. So basically, as you can observe, what I can do is for my any other modulo that can be 0. So basically, if I have any generalized AI mod k equal to some r, for any generalized remainder other than 0, we can just pair them into groups, and I know the resulting configuration of subtracting those elements will always be 0. Right? So the approach for the problem becomes such a way that we can just traverse in my A array. So we can traverse from my A1 up till AN, and then what I can do is I can generate my AI mod k value. And for that particular value, firstly we can obtain a frequency array. So f of AI mod k plus plus. So what I'm doing is firstly I'm checking how many numbers can be formed of how many types of different remainders. So for this particular problem, my frequency array will be nothing but f of 0 will be 2 and f of 1 will also be 2. Denoting that there are two elements having remainder zeros and two elements having remainder ones. So now as we observed, if we subtract any two elements having the same remainder, so my 7 minus 4, I know that the resulting element will have my remainder zeros. So basically what we can do is all the remainders other than 0, we can pair those and we can convert those elements into 0, right? So these two will be paired up, 7 minus 4, and 3 will be inserted. So the after this operation, the next step will be we just paired 4 and 7 and we inserted 3. So 363. And as you know, this all are divisible by my 3. So I can simply pair any of those and the resulting number will also be divisible by 3. So at the end, I can reduce these three elements into a single element. So there's the idea that for all the remainders other than 0, pair them up and convert them into 0, and then all the zeros can be paired together into one single element. So basically, the approach becomes simple that in this frequency array, whichever elements are occurring even number of times, those can be paired up and can easily be converted into having remainder 0, and those who have odd number of elements, their odd number of elements may one single element will be left, and otherwise all other elements will be paired up to get our answer. Like our odd number of elements, only one single element is left, and then all the odd elements can be paired up, they'll form the zero remainder array, and all the zeros will form together one element, right? So multiple elements which are giving zero remainders can be paired together to give one element, and yes, this becomes the approach to solve this particular problem. Now let me show you the code of this particular problem and how do we code this particular approach. Okay, now let us try to understand the code for the following problem. So here we include all the necessary header files. Then according to the question, we input my n and k according to the input format. Then I am a vector vk. Okay, so this vk will be nothing but for each particular element will store what is the remainder of what is the value of that particular element mod k, right, as we discussed in the approach section. Then for all the elements in my loop, I'll just traverse, I input that particular element, and then I store the result or the remainder with mod k, because I know only the elements with same remainder can be grouped up. So I increment its frequencies. Okay. Now what we can do is, as we discussed in the approach section, we'll just simply pair the even remainders or the elements having the same remainders. We'll just pair them two at a time, and then we can simply insert the remainder with element. We can just simply insert the element which will have the remainder 0 according to the principle of modulo. That if two numbers have the remainder as same, when you subtract those numbers, the resultant has always the remainder 0. Right? So based on the principle, I'll be left with the elements having remainder zeros, and all those elements can be grouped together into a single element. So here what I do is initially initialize my count as 1. So basically this 1 denotes all my elements of remainder 0 will be grouped together into one single element. So only one single element having 0 will be left, right? So that's why I initialize my count as 1. Then for each variable, for my I is equals to 1, for my I and k and I plus plus, what I do is I simply check whether that particular number is even or odd. So if that particular number is odd, I simply increment that count plus plus because that number is odd and that pair cannot be from that particular number. So only one number gets excluded from conversion into 0 and it has its value added in the final answer. So yeah, if my number is odd, according to the approach, we can just simply increment that particular answer by 1. Otherwise, my even will be easily paired and converted into elements having remainder 0. Right? And for my final test case, I print my count for each test case, right? Now let us run our code on the sample test cases to see whether everything works perfectly or not. So yeah, as you can see, we got one output of the following test case. Now let us submit our code on the sample test cases, on the actual test cases to understand whether this code works perfectly or not. Okay, so as you can see, we got the correct answer for the following problem, and yes, this becomes a valid approach. Now, let me show you what people can do wrong in this particular problem. So here I have a sample solution. As you can see, the person in the solution has complicated the solution by a lot. Like there's so many nested loops and so many complications, and that is why it has received a time limit exceeded error. So one should keep the solution as simple as possible. And yeah, as you can see, this is the right solution and can easily get you the answers. The chances of making mistakes is also less, and yeah, your time limit, your solution can easily pass within the given time limit. So yeah, I hope this is the learning you got from this video. I hope you like my video. Please like, share and subscribe to our channel. Thank you.